Okay, Akshita, now I am making you host. So please share the screen.
Yes, sir. For the behavior. Okay.
To make it full screen. Yeah, now you start.
Yes, sir. So today we will be going to study correlation and regression for the behavioral economics. And yes, it is. It would be somehow related to social decision making as well. How? Okay. So, what is correlation? When we study correlation, we say that we have got two variables like x and y, and when change in x, like one variable, results in the change in other variable, that is known as correlation. And when we measure it, like the extent to which the relationship changes, then we measure it by correlation coefficient. So it basically measures the strength of a relationship. So we have terms like correlation and causation, correlation and regression. So when we talk about causation, it's what causes another. The cause and effect relationship is clear, like our class 12th example itself that says that if there is proper rainfall fall, then the crop yield would be better. The This is true, but the reverse is not true. Na? Like due to better crop yield, there would be rainfall. So yeah, like this, the correlation and causation has its differences. So in correlation also we have various methods and techniques where we study how they are related to each other. But the only problem is that it's not what it's not. So it does not establish it. It establishes a relationship and quantifies it, but not for the qualitative data. So a correlation is something that, okay, two variables are correlated. It does not establish a cause and effect relationship. So it can also say that it's degree of association between two variables. Like we study demand and elasticity of demand. Na? So demand is the change of demand for a good with respect to price. And when we study the responsiveness of that change, then we study the elasticity of demand. So that's the correlation. And when we move this to behavioral economics, then we study that how much cognitive biases can affect the rationality, or anchoring biases can reflect me. Anchoring biases can cause the response of a person to be to buy a product or to discard a product, reference point. So this can be studied. Okay. So we study so far we know the definition of correlation is the extent or the direction of relationship between two variables. Okay, now there are types of correlation, that is positive correlation, negative correlation, simple correlation, partial correlation, linear and non-linear correlation. So there are different formulas for measuring, like Pearson coefficient. Then there are different which we can discuss in a statistical lecture or any week, like next week, if we decide to keep a class. So let's move on to the positive correlation, which is also called the direct correlation. That is, if both the variables are varying in the same direction, positive correlation. Like x increases, y also increases. That's a positive correlation. और इसका उल्टा क्या हो जाएगा? The reverse is the negative correlation. X increases and y does not, y decreases. So it's like demand and supply curves. Now, simple correlation is when there are only two variables. Partial correlation is like we have got 10 variables, but we understand that only three variables are significant. So we would study only the three of the variables which would be affecting our results. So how do we test that? We do robust analysis in Stata, or different type of methods are available to study which variables should be considered and which not, and then we can do on a partial correlation. Then we move on to the multiple correlation, when there are two or three variables, when we study them simultaneously. Then we have linear and non-linear correlation, when there is a constant ratio, like 45-degree line is forming between x and y axis. The change is like the alpha parameter or the beta, that is constant. The change is constant. When the change is not constant, then it is non-linear correlation. It can be curvilinear relationship, S shaped, U shaped, any shape that can be understood after plotting on the graphical method. So when we plot a diagram, that's a graphical method, also known as the scatter plot. And we have the algebraic method, in which we use the uh, deviation from mean and arithmetic mean. So in graphical, let's study the graphical method. In x and y axis, we have got suppose crop yield and rainfall, and we plot the diagram. And then we have got a the plot is like dots. So we have got straight positive dots. That's our perfect positive correlation. And then if we have a demand curve, like a downward sloping curve, then it would be our negative correlation. So these are equidistance and degree remains the same. The tangent value remains the same. However, we can have the low degree of correlation and the low degree of negative and positive. So they are in a scatter diagram. The graph would be there would be like 45-degree line, but that won't be a like a visible 45-degree line. It would be scatter plots near the points that we plot by dropping perpendicular from x and y axis would be near that 45 line. So that would be our um, positive correlation. Weakly positive and weakly negative correlation. Then we have high and low positive and negative correlation, when these lines are very close to each other, like very there is less degree of variability. And zero correlation when we do not have any. So correlation coefficient is then there can be a we normally study the Carl Pearson correlation coefficient. So if all these points they lie on this like straight 45-degree line from left hand corner to upper right hand corner, uh, we have this perfect positive correlation. R's value is one, like one value. Okay. But when we have this ulta, like negative correlation, like a demand curve from left higher corner to right lower corner on the positive x and y axis, then we have a negative r. Nearer points to be to the straight line, then it may lie between 0.2, 0.2348, like this. And when we have the, where was I? Yeah, when we have, just give me a moment, please. Check. Hello. Yeah. So, hello, am I audible? Hello.
Yes, you are audible.
Yeah, I just switched to headphones because my battery of the wireless headphones died. So where was I? I was telling about the huh. So I was telling about the positive and the negative correlation, and then how from uh, if they are on the straight line, then the far away they are from that straight line key points, the farther is the farther point of the straight line, the lower is the degree of the correlation. Okay, if the point is like 45-degree k line, say they are far away, then that's a sorry, weak correlation. And if they are closer to each other, then then they have a high degree of correlation. Okay, and when they are not correlated, then there is zero correlation, and then that would be scattered around like everywhere on the graph. So, okay, next is, now let's move on to the regression analysis. And in regression analysis, we can also discuss the formula of the correlation. When we for the one correlation is can I okay is my cursor visible? So r key So we have r, x, y, how we denote our correlation coefficient, which is equals to summation of x minus x bar, where x is one variable and other is y minus y bar, over under root of x minus x bar summation. Just forgive I don't have a pen right now. So the battery down there. Okay. So x is
Yeah, we
independent.
are understood.
Yeah, y x is independent variable, y is dependent variable. So this part is our deviation of mean, and this part is also a deviation of mean, and deviation of arithmetic mean, and this is the deviation of mean. So r is greater than 0, we have a positive correlation. R is less than 0, then we have a negative correlation. R is equals to 0, we do not have any of the correlation factors. Okay, now let's move on to the regression part. Okay, I'm so sorry, I'm not well versed with this Zoom um, annotation. Uh, mm, okay, now let's move on to the regression. So, regression also defines the relationship between two variables in qualitative terms. So, it is used to make prediction about one variable or a set of variables having properties like independence, uncorrelated, variables having various error. These are the assumptions. So this is based upon our knowledge. So one variable x and the other variable, which is the variable based upon our knowledge. Now this is now we can have we can have simple regression as well as we can have simple linear regression, and we can have multiple regression. So why do we use regression? We use it for the prediction. Regression is used for the prediction, like value of one variable, x variable, when the value of other variable is already known. So basically it's defined as a relationship between two or more variables, where we use one variable to predict the other variable. So we estimate or we predict. What is the difference between estimation and prediction? Normally we use it like similar terms, but somehow someone said that estimation is for sample and prediction is for parameters. Like parameter is for the entire population, and sample, for sample there is estimation. So normally we have got a bivariate data for the regression. Like, okay, so how do I go from this slide to next slide? Types. Regression. Now we will discuss basically three things in this regression. So regression is also known as the OLS. Oh, I forgot. It's the line of ordinary least square, and we can derive the line of best fit graphically and mathematically and statistically. And I'll just explain it to you how how we would do that. So we can have x on y and y on x. So when we say that the equation having the change of y for the change of x, then we say that we have an equation of y on x. You'll find it in various books of statistics, economics, econometrics. And x on y is described when we have a x value and then we give it for the change of y value. Okay, so we know the value of x, and we have the knowledge of x, and we want to know the y. So it's the one variable is dependent variable and the other variable is independent variable. So जो हमारा left hand side variable is dependent and right hand side वाला variable is independent variable. So these are the regression equations that we can have. We can have it mathematically also. So let's see now. Now see, today, in today's world, we have studied regression statistically. We have studied regression for R and various softwares, but now we have moved on to the regression when we are going to teach the machines. Okay, so now we have got an input. Now we have got input to the algorithm. So what is an algorithm? First of all, algorithm is a set of rules. Now, set of rules is like simple cooking a recipe. You know what are the inputs and you know the output. The process has to be monitored. Same is the case with the computers or the big machines. We have an input, a set of rules, and we want a output. Now, if this output, the output that we get is a hypothesis. Okay, so we have two hypotheses, the null hypothesis and the alternative hypothesis. Now this hypothesis is a strong assumption, and now you have to test this hypothesis. So this hypothesis will get an input, and the machine, the AI, will give you the output. So suppose you have given you have x is given, and you have to find dy. So let's say that size is x and prices are y. Okay, so these are sizes in feet, square feet, assume whatever. 2104, and these are just random numbers that I have taken. So let's say you want to predict the prices of the houses, and you have x variable as size and y variable as price. Now you want to say that x X is size and okay. So this is the price, this is the size, and this is the output cost. So how will you go about it? Just give me a moment. So when we have a linear regression, normally this is the how we will plot it on a graph. That on x-axis there is we can determine it scatter plot, but we cannot predict the actual predictions of how is it going to go. So let's say now we will assume hx. Okay, hx is to be hypothesis. You understood now? We give inputs and then we get outputs, and h naught is our hypothesis. That is a strong assumption. And now in this hypothesis hx, we have to put our hypothesis is q naught plus q1x. Okay, and this is also known as finite function. So this is for two things, like for variable output, like when you would put the value of x over here is okay. Feedback hub, we do not want feedback right now. X1 is the the land. This is the house. Now if we suppose we increase the variables, like we have size plus number of bedrooms and prices. So now our hypothesis would be hx is equals to q naught plus q1 x1 plus q2 x2. Okay. Now you already have a data set. You can feed it to this I have already covered. So now you have to feed this to SPSS data R learning algorithm. So now you have to get an output function from this algorithm to make predictions about the future of the housing price. And we say that this function forms our hypothesis. So hypothesis are strong assumption. H naught is the hypothesis of no difference, where we assume that our predictions or our outputs would be correct, and HA would be our alternative hypothesis, where we say that the assumption that we have made is not true. So input the size of the house, output is the estimated cost of the house. So how we present hypothesis h and hypothesis going to be, so this is the two methods that we present the hypothesis hx, which is equals to q naught plus q1 x1 or q naught x, and hx would be q naught plus q1 x1 plus q2 x2. So this is what we have. We can add the number of bedrooms 3, 4, 5, 6, and so on, and these will take variables would be in xi form. So xi is that I can take the I, like the small I can take value from 1 to n. This is kind of a continuous data that we have. So now already we discussed about what is a parameter. And so yes, this I'll go later. First, let me define hx when we have I number of values, which is from 1 to n. So our hx would be equal to summation of j is now what is j? J is the cost of the output function. The cost would be the two variables that we have, 0 to 2, and our that would be qj and xj. So our x are 2 now, 1 and 2, and q would also be taking two values, 1 and 2. So where now
Hello,
we,
Akshita.
yes sir,
Hello, Akshita.
yes sir.
It is related to the behavioral economics.
Sure, sir.
Okay.
It is
And your
related to the
yeah,
behavioral.
and your variable is size and price. So how it is related to the behavioral economics? It is not
Sure, sir.
related to the social influence or
No,
something you have told, na?
Yeah, sure, sir. So, what we will do is that when we will study about the implication, I'll just give me a moment. I'll just resolve the query. I just know how to delete clear all drawings. So here we will assume a person would be on X on this, and he or she has to find the optimal point to reach the Y gradient descendant mechanism, which is used in various algorithms and softwares. So these are the optimal functions that we want to get to. But these optimal functions would be depending upon vectors. The vectors would be of X and X and theta, which would be our linear vector taking different sort of values. Now these cannot be always optimal. So to produce, see, this would be a quadratic function. उसका जब हम डेरिवेटिव करेंगे अपनी हिल वाली जो वो पहाड़ी वाला होगा, उसका जब हम डेरिवेटिव करेंगे तो वो हमारा क्वाड्रेटिक फंक्शन में आएगा, और उसके अंदर हम ऑप्टिमाइज करेंगे कॉस्ट फंक्शन को, क्योंकि हमारे पास बहुत सारे वेरिएबल्स है, because land is like huge and we have got variables like Himachal, Dehradun, Chandigarh, various variables, तो वो optimal solution पर नहीं आता है. So it can also get a suboptimal solution. Now this suboptimal solution is like कि अगर 5-10 रुपए का या 5-10 का फर्क भी आ रहा है, so it's okay. Now that suboptimal solution is sufficing. When we say that okay, we have got a software, we have got our algorithm, but algorithm has got biases, maybe due to data or maybe due to the algorithm bias, then these biases can take a suboptimal output, and then we are suffice. I'll give you a very simple example. Suppose I ask Gemini or ChatGPT to generate a lesson plan for me, and then I'm like, okay, I won't be able to do it so well. This is something that is like better than me, so I'll take that solution without entering more prompts, more proper prompts to it. We have a separate branch of prompt engineering for it, which do not require engineering background. Without entering the optimal prompt, which would give me an optimal result according to my requirements. So there also I am like like suboptimal solution. I'm choosing a suboptimal solution. So this was what I was going to explain, and I was also going to explain that why these tangent while these derivative forms eclipses, and how these eclipses have a 90-degree angle for the best path to be determined. And I can, like, if you want, I can explain it mathematically and statistically, and then I can also go on with how this equation is the best fit equation of best fit equation for our OLS method, when we take a derivative of vector x with respect to theta, which is our parameter, which can be equated to our this theta can be equated to our x and y when x is indexed to ith number of background processes, and y is also indexed to it. So xi would be our xi2104, x1i, like x1 variable is indexed to I for 2104 square feet of land, with the y y1 ith variable indexed to 4 lakh rupees. Then 1416 would be my x2 ith variable with, so we can have the n number of variables, but with n features, because we have got only 2 features: number of bedroom and the size of bedroom. Then we have got x and theta with 1 plus n dimensions for the algorithm. Like we take for the degrees of freedom n minus 2, you can consider it as a rule for 1 plus n for the dimensions. So our theta would be a वो horizontal वाला जो vector होता है, जिसके अंदर we have only got columns from q0 to qn, and then we have got our x from x0 to xn. But of course, these are only notation and hypothesis, where notation and hypothesis are interchangeable. So yeah, this was my lecture, and how can we relate it to the biases, the anchoring biases relation, and suboptimal for regression. How do you want me to go about it? Mm. Any questions so far? Okay, first let me relate the correlation thing uh, to
Now,
the
Akshita, that is not clear how social influence affects the price. You have shown that is the how size is related to the price, but my point that is how the social influence can influence the price, because it is the behavioral economics. So therefore, you have to think the independent variable or the moderated variable from
so
the behavioral economics point of view.
so what we can do is that we can introduce the dummy variables that we studied earlier for SPSS, for social influences, and those variables can be regressed. So if we have to say, we have to capture the anchoring effect, then we can say that if there is an anchoring effect, we'll put a variable 1, and if there is absence of anchoring effect, then we can put a variable 0, and then we can predict on the basis of the dummy variables. However, I've not done this or read any research right now regarding this, so I'm not sure how can we generate an optimal output, but of course we can have a suboptimal output for that, which can demonstrate the anchoring effects impact on prices. Suppose my anchor is some plot in Kolkata and I am moving to Delhi. So, of course, there is displacement from Kolkata to Delhi. However, I'll try not to get my anchor in between the prices uh, and the negotiation or the bargaining. But of course, there is not just one person that is doing. There are hundreds of people who are moving from Kolkata to Delhi. There are people who are moving from Shimla to Delhi at the same point of time. So these all things can happen in an algorithm when we give it a command to repeat the same parameters that we have fed into it. And we have to use so we do not want our syntax error to come, so we use uh, this is the approximation sign. So like q can take any values like qx I. So we can say that it can take open values like o1, o2, o3. So these values can be a set of values like library files, and then we can predict it with different variables. We can increase the number of variables on the independent side.
So this is your dummy variable.
I have not studied any research so far if they have conducted, but no, we'll have one variable as say the price x1 indexed to I. Then we have another variable x2 indexed to A, and then this would be anchoring effect when anchoring happens. So it would be forming a matrix over here, which would have the characteristics जो properties के result होते हैं, and then we would have our x3 that is absence, like 0, like the dummy variable. 1 is presence and 0 is absence. It would be easier to initially it would be easier to.
Okay, you go to our Google Classroom. We have already written.
Okay, sir, sure.
Farah has already written the regression, R script,
Yes.
and other
Okay,
things.
sure. I don't know how to. I can just Google Classrooms.
Okay, now you stop share.
Yeah, yeah, sure. Stop this.
So here is the regression analysis. The problem statement is a coffee shop wants to understand the relationship between the price of a cup of coffee and the number of cups sold. So here they collect the data on the price and number of cups sold for 10 days. First one is the day, second one is the price, and third one is the cups sold. We will use the simple linear regression to model the relationship between price and cups sold. So the regression equation is cups sold. Cups sold is my dependent variable or predicted variable. And next is the intercept plus the beta coefficient multiplied by price. And next is the error. So this is the data. First day, price is 2.50 and cup sold is 100. Next day, it is 2.75 and cup sold is 90. Third day, the price is 3, cup sold is 80. Fourth day, 2.25 and cup sold is 110. Now in fifth day, price is 2.50, cup sold is 100. Now you have noted that when the price is 2.5, the capsule is 100. And when it has crossed the limit, then the capsule is reduced. That means when the price increases, capsule is decreasing. Here you can find out when the price is 2.25, capsule is 110. And when it becomes 3, then capsule becomes 80. Here the result shows for every $1 increase in price, capsule decrease by 20 units. Therefore, your intercept is minus 20. Sorry, your predicting variable equal to minus 20. The intercept represents the expected number of capsules when the price is 0. If you think that is the price is 0, then what will be your expected number of capsules? By using the regression analysis, we predict capsule for a given price. For example, if the price is 2.50, predicted capsule equal to 120. 120 is the assumption that if price is 0, then how many cups is supposed to be sold? So 120 plus 20 into 2.50. This indicates 100. If the price is $3, then the predicted capsule will be 80. This example illustrates a simple linear regression analysis. And our script for regression is this. First, you have to create the data frame. Data frame includes the day and next price. Third one will be the cup sold. Then you can check the data by using the view command. Then there is the model. Model is linear modeling. LM means linear modeling. Capsule is your dependent variable. Tilde price. Price is your independent variable. So finally, you will get the summary of the regression model. So when you will write down summary of the model, then you will get the coefficients. And if you are interested to make any plot based upon the coefficient, then you can do this thing. That is plot the data, then plot coffee data price. So what is your independent variable? That will be at the first. Next is the coffee data cup sold. That is your dependent variable. Then main relationship between price and cup sold. That is basically your title. X lab is the price and Y lab is the cup sold. So your independent variable will be on x-axis and the dependent variable that will be on the y-axis. Then you have to use the regression line. Therefore, you can write down ab line. And in bracket is the model. And the linear modeling, the first one will be the dependent plot. Then first will be independent variable. After that, dependent variable will come. Accordingly, you will get the line. Next is the residual. Residual, it includes predicted values, comma residuals. What is your predicted value? That is already extracted in your program. That is your predicted value. That means your observed value to what extent deviated from the predicted value. That is your residual. So this is all about the simple regression related art script. And if you want to use the multiple regression, then you have to use the plus sign. Here you can see the perform multiple regression analysis. So the model equal to linear modeling, enroll, tilde tuition. Here the data set is different. Here the purpose is to find out the student enrollment determinants. So tuition is the variable, room board is the variable. And like the simple regression, you will get the multiple regression data. Also, you can do the plot and the abline. Here you will get the abline in red color so that you can easily identify the residual, that is the deviation between the observed and the predicted value. So you will get this thing. First one is the enroll. After that, what is the tuition cost? Next is the room and board cost. Another one is the private or public institution. That is also your predicted variable. Now here you can find out your predicted variable. So this is the intercept. Enrollment is related to the tuition, room board, and the private. Residual standard error is 494.10 on 766 degrees of freedom. Multiple R squared is 0.35. Adjusted R squared is 0.34. Therefore, the interpretation is the R squared value is 0.35, indicating that about 35.45% of the 45% of the variation in enrollment can be explained by the predictors, tuition, room and board, and private institution. So these variables, they have the effect on the student enrollment. Next is the coefficient. The coefficient for tuition is minus 0.042, indicating that for every $1,000 increase in tuition, enrollment decreases by approximately 42 students. This suggests that higher tuition costs may deter students from enrolling. Like that, you will get the room board, private, and after that p-value. P-value means it is significant or not. So whether you can generalize this data, this point is vital. So this is all about the regression. Now here you will find out that is the psychological or the behavioral economics point of view. That is the tendency of the human being to save the money. Therefore, when the price increases, then the enrollment decreases. Similarly, in case of the coffee cup selling, you have noted that is the higher price level leads to decrease in the coffee cup sold. So in this way, you can justify that how persons or how the consumer's behavior is guided by the change in economics. So we have given everything in the Google Classroom. I am requesting all the students, please you study these data in the Google Classroom. You can apply it also. Using your own laptop, you will be able to use it. So thank you, Mona Lisa, Ukshita, and Farah.
Thank you, sir.
It is available in the YouTube, so you
Thank
can
you, sir.
check it. I'm requesting Ukshita, please you prepare the template for the last 3 days. The template is not there. We have to use the template and the description part also.
The template, which template?
Template for the YouTube video template by
Oh,
using the Canva. You can do it.
okay, sir. Yes, sir.
Mm, thank you.